I propose that you sit because we have to start.
Bueno, ¿se me oyes perfectamente? ¿Sí? Aunque hable por acá. Esto es...
Okay, so I propose that,
bueno, les propongo entonces de que empecemos esta discusión de la mesa redonda que está dedicada al espacio y al clima. Aquí la idea es de que discutamos nosotros cómo las agencias espaciales contribuyen al seguimiento y al manejo del COP21.
Major space agencies worldwide, and what I propose is to make a short introduction to remind you what is the Paris Agreement, and after that we will enter directly into our topic, and I will ask questions to my panelists. So could you put the presentation on the Paris Agreement? Could you put the presentation? We have a small technical issue. It's not launching a satellite, it's much more complicated. Okay, so we can start. So you probably know that we had last year the COP21 conference in Paris, and all of us have been fully engaged in the global effort to curb global warming. And these combined efforts put space firmly on the agenda at COP21 and led on 12 of December 2015 to the Paris Agreement, which is a historic success, paving the way for sustainable development decisions and laying the foundations for concrete action. Why did we insist on the role of space? Because space is definitely the only global and continuous observatory. It is the only means of achieving global coverage, continuity of observation, simultaneous monitoring of different variables at global, regional, and local scales, and of delivering data rapidly to our stakeholders. Just a figure. Of the 50 essential climate variables, 26, more than half, can only be observed globally from space. And I should say that in a changing world which is beset by climate change, no single nation can tackle this challenge alone. Cooperation is vital, and this is particularly true for space, and this is why in Europe all our missions are developed in close cooperation with our partners. We have also the question that satellites will monitor the decision taken by governments by measuring greenhouse gas emissions. And in the future, following the decisions of the COP21, we are sure that satellites will play an increasing role in this area, creating a new ecosystem devoted to climate control monitoring. Definitely, this is a worldwide effort because the climate threats and extreme weather events are the plagues of our modern age. And in the face of these threats, I can say that space today has a unique responsibility on its shoulders. Space agencies cannot provide the solutions to curb climate change, but I can tell you that without space agencies, no one ever will. And this is why, because of this new sense of urgency, that we held, all of us, last April, a symposium in New Delhi, the IPRS 2016 symposium. And the conclusion of this symposium is that, in fact, we provide an excellent opportunity to maintain momentum and consider how to implement and follow up the Paris Agreement. This led to what we called the Declaration of New Delhi, which was formally endorsed in May by all of the world space agencies following consultation with the CEOs. And I firmly believe that the spirit of the COP21 agreement must be sustained and that the World Space Agency are ideally placed to contribute to the spirit of global cooperation with a new sense of urgency. So this is what I wanted to say as an introduction, and now I propose to give the floor to my fellow panelists, and to start, of course, with Mexico, with Mr. Mendieta, the head of Space Agency, because Mexico, and in particular IAM, the Mexican Space Agency, committed itself to tackling climate change via the Declaration of Mexico on climate and its risks. And the question, Francisco, is what are the key pillars of this declaration and what role does Mexico see for itself?
Thank you very much. I will need the clicker. Maybe I will, yes, I need this and the clicker. That's multimedia. Thank you very much. I'm very proud to be in this plenary. I have this presentation. First, I only want to read the fifth line, only the last line. These are the 5 major governmental axes of the Mexican federal government in this administration. And of course, peace, inclusion, education, prosperity, but global responsibility also. And we are willing to share with developed and developing countries the information for climate change and natural disasters. First, available information. Second, having our own ground stations. And third, cooperate for certain payloads, specific satellites, specific orbits in the long or medium term. And the other is contribution from actions also related to link with in situ measurements in boats, buoys, climatic weather stations, drones, and so on. And of course, that can be done only by international alliances. This, an example was the summit of heads of agencies that took place 1 year ago in Mexico City, from which emerged the Declaration of Mexico on the climate change from the space perspective. We observed the enormous contribution of space observations to the climate change evaluation, monitoring, and tackling, the contribution of Earth observation satellites to understanding and strategies, how the Earth observation can reduce the vulnerability in natural disasters, how combined Earth observation, SATCOM and GNSS can reduce the carbon footprint, and the necessity of international cooperation that serves for many things: identification of common challenges, joint development of space-based solutions, complementarity in space information systems, and of course, participation of developing countries in great missions of humankind tackling these global challenges. Previously, we had gathered together with 12 agencies under the umbrella of the International Academy of Astronautics, in which more oriented to natural disasters than climate change, but it has been progressing up to now, about academic cooperation, access to satellite data, information exchange, and of course, regional space infrastructure in several niches of opportunity, and the more important is capacity building among our communities. This has been pursued in other forums, such as organized by other agencies, particularly India. The President of India came to Mexico last June, and he presented the climate change as a joint challenge in which more detailed activities are arising, such as especially measurement of several greenhouse gases, need of hyperspectral measurements, how the need of invest in the specific research satellites, and a need of coordination for calibration and universally accepted data. That's the perspective from the Mexican Space Agency. Thank you.
So, thank you, Francesco. So I propose that now Jan Werner speak because ESA has been strongly committed to tackling climate change ever since NVSAT, and it also has its climate change initiative, weather satellites with EUMETSAT and Sentinels with VEC, plus its Earth Explorer program. And I want to ask you, what are ESA's current priorities and future projects in this domain? Jan, the floor is yours.
Thank you very much, and I hope you can hear me. I heard that some of you stayed even overnight to understand what climate change is, so I'm very happy for that. So thank you very much. So I would like to talk a little bit about this issue in a different way. I'm not presenting what we can do or everything, but I would like also to give a little bit of spirit what we should do in the future. And the first thing is, of course, I'm showing this picture right often because there are all the global challenges. Today, we are discussing about climate change. Why is it so important? If we look into our world, we see planets. And let's assume that a planet is meeting another planet. One is very nice, blue, shining, and the other one dirty, gray, very bad, very bad. So the first planet, the blue planet, is asking the other one, "You are looking very sick, what happened to you?" And the other one is answering, "Oh yes, I'm sick, I got Homo sapiens." And what we should avoid is that the first planet has to answer, "No problem, it doesn't last long." So it's really our responsibility to do something for this world, for this Earth, to maintain it in a solid situation. And this is what we can do. And Jean-Yves mentioned already that we have these different types of measurements we can use from space. We can observe more than 50% of all the climate variables from space. And therefore, we can give a very special input for monitoring. But monitoring is one thing. And we at ESA, we are doing this by providing different satellites. We have the so-called Earth Explorer missions, where ESA is doing research in new fields of Earth observation. We are doing more the operational part together with the European Commission, the Sentinel missions. So we are the guardians of the Earth. And then we have the EUMETSAT missions, where we are looking especially to weather and climate change. And all of these satellites, especially from the Sentinels, from the from the European Union, they are now in progress to be launched, and we are in an ongoing process. We are not only looking to one satellite producing some data, but we have a serious and a long-lasting history in front of us in order to monitor all of this at the same time. But what is important, and this word of big data you heard already is used usually in a wrong way. It says big data is a lot of data. This is the wrong interpretation. Big data means to putting together the data from different sources, from space, from air, and in situ. And this is done also with the Sentinel data. So we put them together, we are processing them, and through that we get big data, and through that really the information we need. And this is the way it works. For instance, if we are looking to the ice shield, the change of the sea ice volume is an indicator for the question of how is our planet heating up. Or sea level rise, it's another very important indicator. And I come back to COP21 when John Kerry said a very important message, and I will quote him directly. You will see it directly on the screen. He said, "I know I know there are still a few who insist that climate change is one big hoax, even a political conspiracy. My friends, these people are so out of touch with science that they believe rising sea levels don't matter because in their view, the extra water is just going to spill out over the sides of a flat Earth. He added, and we know it's not like that, but I think I can neglect this one. So therefore, we have to look into the future and we have to look to all the things. Here you see the idea of CO2 measurements in the future, where we have to make a difference between anthropogenic and biogenic CO2 and look to it how it is developing. I'm quite sure this cannot be done by one agency, by one nation or one entity. It has to be on a global scale, worldwide cooperation in order to have the acceptance also worldwide. And climate change is more than just observing. Of course we are observing, but we also at the same time have to try what can we do against it? For instance, looking to irrigation of the ground. We can, from space, we can immediately and directly say where to irrigate and what to irrigate. So this is a proactive help, not only an observation. Precision farming is something we need also, especially for climate change, in order to give the possibility in the future to have agricultural food done by precision farming. So space is then linking together. And a very strange aspect, but I would like to add that, the development of new plants, which are even climate change resistant, can be done with the help of space. We did some experiments on the International Space Station just in order to give this. So what I think is space and climate is much more than observation. Yes, it is observation, but at the same time it's monitoring for a long period. It is information for the public, for the politicians, for the decision makers, but it's also helping for the food supply of the future, for instance, through precision farming, water management, waste management, but also the development of new ideas. And finally, and not to be neglected, space can be used for education. And I think all of this together, we can then come to a better world in the future. And therefore, we are using the term of Space 4.0, I standing for innovate, inform, interact, and inspire. Thank you very much.
So, thank you, Jan, for this very comprehensive and very inspiring presentation. And I am sure that all the young people who spend the night here to wait for it are very, very happy. Please applaud once again because it was very inspiring. So the next speaker is NASA, because NASA is very well involved in this climate change effort with a mission dedicated to measuring carbon dioxide and with the OCO2 satellite. And I want to ask Hélène, what is OCO2 teaching us about greenhouse gases and what other projects does NASA have in store?
Thank you. As Dr. Warner was just telling us, climate change is the most serious effect, that this Earth is facing right now. And unless we as a global community really start taking action, and it's, not just what we decided in COP21 in Paris, but even moving beyond that to try to hit the 2°C mark is incredibly important. And space, as we've heard already, can play such a clear role in trying to understand what is happening in the atmosphere, how that's affecting the sea, how that's affecting the ice at the poles. All of these things are critical, and space plays such a critical role. In terms of carbon dioxide, I think it's really important to get back to that really simple premise. You can't manage what you can't measure. And so that's, again, where space-based assets can play a role. With the Orbiting Carbon Observatory 2, that's been in orbit now for about a year, along with the other international satellites that are measuring carbon dioxide, we're really starting to get a handle on how we look at carbon as a changing component of the atmosphere seasonally, yearly, annually. Unfortunately, we have to build up this data set to really understand what are the sources of carbon dioxide and what are the sinks. We already know that over half of the carbon dioxide that is put into the atmosphere doesn't stay there. Where does it go? And the fact that it's going, for example, as we know, into the oceans, causing ocean acidification, how stable is that process? How does it take place? And is it going to continue at the rates it is, or else we're going to have even more carbon dioxide in the atmosphere, causing even more warming? So watching the sinks of carbon dioxide are just as important as watching the sources. In the OCO2 data, we've already been able to see a lot of seasonal variability. Obviously, you can see the plant cycle very much in the carbon dioxide data. But then we want to get at what are the human-caused sources of CO2. And again, we can see that fairly clearly in the data, where we can see the major industrial areas producing carbon dioxide across the year. And we can see quite clearly the results of vegetation burning across multiple continents, as through farming and deforestation, people are doing huge amounts of biomass burning. All of that is visible in the OCO2 data. And again, it's not just going to be OCO2, it's going to be the constellation of international satellites measuring CO2 at ever better resolution. We're moving on post OCO2 to OCO3, which will be built from basically spare parts from the orbiting carbon dioxide observatory. It will go up on the space station. OCO2 has a lifetime of about 2 years. We hope it'll live much beyond that. OCO3 will go up onto the space station in a few years, and we'll extend that. Most of you probably know that what's next really comes for NASA through the decadal survey process. And our National Academy of Sciences in the United States is right now undergoing this decadal survey process for Earth science, where the Earth science community is coming together, having discussions saying, what are the next generation of measurements that need to be made? What is the resolution at which we can make these measurements? What is the repeat cycles? How do we need to make these measurements? So we're taking into account the data that's been collected and looking towards this next generation of measurements that will be made. And that decadal survey process will come out, the recommendations will come out in about 1.5 years. So again, I think it's really critical that all of us are up on stage together, because the only way that we're going to effectively deal with climate change, and dealing with it means making sure that we're understanding what's being put into the atmosphere so that we can understand how much worse it's going to get, but in particular, at this point, making the measurements that need to be made so that as a global society, we can be resilient to the effects of climate change that are now going to occur no matter what we do about carbon emissions. And NASA just last week announced a public-private partnership called PREP, where we're partnering not just with non-governmental organizations like the World Resources Institute, but also corporations like Google and Amazon, to get this Earth science data out, not just to scientists, but to policymakers and people who need the information. Thank you.
So thank you, Hélène, for this description of the huge effort which is made in the US and all those prospects that you have in front of you, which are very, very promising. Now I would like to give the floor to Roberto from the head of the Italian Space Agency. Roberto, as he made a lot of efforts this last year in Earth observation with, in particular, the Cosmos SkyMed satellites, and how do you see the future of your activity in Earth observation, and how do you connect it with climate change issues?
Thank you. Italy, as you know, is located in the Mediterranean basin in a location which is extremely sensitive to climate change for a very simple reason. People from areas on the Earth which are affected in a negative way in Africa, in Asia, by the climate change are traveling to Europe often, and one of the countries which I encounter first is Italy. So we have consequences of the effect of climate change, which can be measured on a daily basis and very often in a tragic manner. So the role of space is not only to monitor the variables and to provide instrument to improve and make better the way the environment is handled at home, but also to monitor what happened when people move away, the crisis which happened in the middle of the sea, and all kinds of phenomena which require overall intervention and space from this point of view is extremely effective. I think we have to act on a number of aspects. First of all, anticipate the phenomena which are damaging the population. I'm thinking in particular the drought or the floods. Imagine that instead of driving through the traffic in your city, you can anticipate and know what is happening to the river, to the source of water in your country. I mean, people are traveling, even the poorest one, are using phones. And in phones you can have application, and this application can carry information which can help them anticipating the way the agriculture should be implemented, anticipating the difficulties which can derive from having the knowledge of the weather and the climate changes in the short time. All these kind of things are extremely important and also are part of this global activity which is induced by the climate change observations. Of course, there is an issue for space can really support is providing understanding of what happened to the borders, especially on the marine side. This monitoring from the space and the integration of this information with all kind of instrumentation is also extremely important. And all of that is part also of the intervene capability when there is a crisis ongoing. Space can provide essential information to avoid the most terrible result out of a situation which are out of control, and we read on the newspaper that every day. We, as was mentioned briefly by Jean-Yves, we have a strong tradition in the SAR observation of the Earth. We have the largest constellation of satellite, Cosmos SkyMed, which has been recently approved to move from 4 to 6 satellites. But this is on the X band, can provide a certain number of information, especially on space resolution. But also all the other bands, we are collaborating with Argentina on the South Concierge program, on the same orbit, providing X-band and L-band together. 2 satellites will be launched on 17 and 18. And we are now anticipating the future, because space is always about frontier, so bringing this SAR capability to geostationary orbit can allow us to monitor very large part of the continent. So we started this GeoSAR initiative with Roscosmos exactly to bring this peaceful application of SAR to the geostationary orbit and monitor to very large scale as a background information, all kind of phenomena which are typically monitored on a short scale by mapping over with a recurring observation period of a few days. But we are also looking into the future for hyperspectral. Hyperspectral can provide essential information for the kind of environment information, pollution, agricultural information. And this is the PRISMA project, which will be launched in 2018. And we are now developing a program with Israeli about the Shalom, which is the first fully commercial application for hyperspectral, which is expected to be operational in the early 20s. All of that, however, all this space segment can provide really the potential of his effectiveness only if it's being used effectively. And as has been mentioned before by Jan, unless we can provide to a very large amount of people this information in a very easy way, all this information will be only partially used by scientists or planning, management, and government. We need this information to be provided to the individuals, and for that we need a revolution, because we need the same capability. Now we have a GPS, this capability we should have with the variables which are related to the climate, to the weather, to the environment. And this is really a revolution which requires a lot of ideas on how to do that, how to take out the value of the information of the space segment data into everyday life. I repeat, people of tomorrow will not only navigate through the cities using the satellite, they will navigate through the environment using the satellite data. And I think this will provide a revolution which we only see very little today and will be very surprised tomorrow. Thank you so much.
Thank you. Thank you, Roberto, to show how Italy lead the way in the Mediterranean basin for this very important challenge. And now I propose that we go on the other side of the planet with my friend Naoki Okumura, head of the JAXA. So the floor is yours.
Good morning. Thank you very much, kind introduction. I would like to tell you this morning to you the specific, very new outcomes produced from the measurement and analysis of GOSAT, as JAXA is a pioneer of the measurement of greenhouse gases from the space. Actually, Japan's effort to create a uniform measure from space was driven by the Kyoto Protocol adopted in December 1979 at COP3, almost 20 years before the Paris Agreement was achieved last year at COP21. As a result, our GOSAT became the world's first satellite designed exclusively to observe greenhouse gases. It has been operational on orbit since the launch in 2009. With GOSAT, the 320 ground CO2 observation points were enhanced to 56,000 points around the globe. The recent press release made by the Ministry of Environment, the National Institute for Environmental Studies, and JAXA announced that the analysis of accumulated GOSAT data was performed for the Tokyo metropolitan area in addition to major cities over the world to calculate anthropogenic carbon dioxide concentration. The result of the comparison of the analysis with the emissions inventories showed a very good match, which is demonstrating for the first time the possibility that satellite observations can monitor and verify the emissions reported by countries, even at the scale as small as Japan. So, JAXA, with its partners, will continue to improve the methodology of analysis and the data accumulation, and to compare the observation data by GOSAT and its successor GOSAT-2 with inventory data. Regarding GOSAT-2, it is planned to be launched in 2018. GOSAT-2 is again developed jointly by JAXA and the Ministry of Environment and its research institute. It is a continuation of the GOSAT mission with upgraded observation capability to meet higher demand of information required by the Paris Agreement. For instance, observation accuracy of GOSAT-2 is 0.5 ppm CO2 as compared with 4 ppm GOSAT. Another aspect is GOSAT-2 is improved in pointing capability for observing large emissions sources. So now Japan is proposing to the IPCC to include guidelines for standardized format of the use of the satellite data for verifying national inventories. We are also working to produce standardized product of the land observation database using our EROS-2 mission. Together, these will contribute to the world effort toward monitoring the state of the global carbon cycle and the effect of the Earth's atmosphere, and to help countries achieve the international responsibility. Thank you very much.
So thank you, and congratulations for all what is done in Japan, in particular with GOSAT, which paved the way for new projects. Now, I propose that we move back to Europe with Pascal. Pascal, we know your personal commitment in climate change. In particular, you have been very, very active in deciding the Merlin that DLR is going to develop with CNES to measure the methane in the atmosphere. And so, what is your view on the role of satellites to curb climate change?
Yeah, I have some slides. If they are not coming, I sit down again. No, they are here. And the participants, I'm very happy to speak briefly about Dlr Activities. We are pioneers in Earth observation. It's a very important topic in Germany. And we are improving climate models, monitoring measures for climate protection. This is something which is a very, very important topic in Germany and for DLR. And there are many missions which we have been working, and I'm just looking at the one in the near future. One mission which we just more or less bring to fruition with CNES is Merlin, which will measure for the first time with very high accuracy the methane budget cycle in the atmosphere with laser technology, and a mission in 2070, NMAP, which is a hyperspectral satellite which will measure geochemical and biophysical parameters everywhere across the world. And Tandem L is a new concept which we are working on in radar technology, which will allow us really to look at the whole dynamic processes of the Earth. And something which I think is really important for DLR. DLR is not only space, and I want to bring this into this discussion. DLR is doing aeronautics, space, energy, and transportation, also security. And we are using actually our interdisciplinary research fields, to understand and to contribute to COP21 goals. And just to give you an example, we have a fleet of 12 research planes. And we work a lot on trying to reduce emissions, one of the major goals for COP21. And we're looking at technologies for more efficient aircrafts and also air traffic management. And with our research planes, we look at actually new alternative biofuels, but also the impact, for instance, of contrails, which we perform together with NASA. And with our all fields, energy, transportation, and aeronautics and space together, we are trying to find synergy projects and try to look for environment-friendly synthetic hydrocarbons. We are analyzing solar thermal system and analyzing electrical systems. And I think it is very important in the future to combine space observations with all the other fields in order to have a complete picture to contribute to the climate change. And we can really do that at DLR. We are very lucky. So in summary, I want to say we are trying really to do unique research and have synergies between our 5 research areas, but also our space administration and our project management agency in DLR. And we are developing technologies to reduce emissions, but also to observe greenhouse gases, to perform climate system research, and also provide data for policy advice. And just to show you, we had the first DLR UN SPIDER conference on climate change in April 2016, and we want to continue this series. It was a very important highlight, and I think to unite everybody in these trials in order to really contribute to COP21 games, I think we have to work all together.
So, thank you, Pascal, for this huge effort, which will culminate in the coming years with the launch of Merlin. And speaking about launches, I want to congratulate my friend from ISRO, the Indian Space Agency, for the successful launch yesterday of the PSLV with the SCATSAT mission, which, as a matter of fact, will be quite important for climate change. And now the floor is yours. Thank you.
Can I have the slides, please? Ever since the beginning of our Earth observation system in ISRO, we have been focusing on collecting data, which is basically going to support our efforts for the growth of our nation in terms of utilization of the Earth resources. Of course, the result of those efforts in terms of Earth observation has been collection of data, which is useful for climate studies. Today, we realize that the essential climate variables, significant number of them could be observed through space-based systems. You can change the slide next. Okay, good. We had a series of satellites basically focusing on climate and weather studies. Today, the whole system which we have established, I will just give a glimpse of what has been done by ISRO and also our future plans. In India, the Ministry of Environment, Forest and Climate Change is responsible for the climate change coordination. Of course, the ISRO support this activity through the space-based observation systems. We have a Center for Climate Change Research in climate change research in the Indian Institute of Technology. And also we support the climate change research program through our ISRO Geosphere, Biosphere research programs, and also NICES, which is a National Information System for Climate Change. We also have our ISRO centers spread across various parts of our country, working on the sensor development and coordination to provide the space-based services. We have a web portal which is called Bhuvan, which is basically focusing on India and associate regions. We have a MOSDAC, which is a database system which is providing the climate and other related data to our scientists and engineers who are working in the climate research. Of course, the issue of carbon cycle studies, we have been discussing a little bit on this. We have the ISRO Geosphere, Biosphere program, which is focusing on this data, which is, we have the Earth-based collection system, which is the flux towers, and also land-based observation systems. Himalayas maintains as one of the important elements of our climate change studies. Of course, the Himalayan cryosphere studies, we have the Earth observation-based inputs, which is feeding into the snow cover, our seasonal and interannual variability, the glacier inventory and its characteristics, mass balance, and also the implications of snowfalls, runoff, etc. Our Earth observation system spacecrafts, they have a series of them. We call them ResourceSat, Cartosat series, OceanSats, InSat series. Many of them you can see here, they feed into a large amount of space-based observations. The ResourceSat series feed into the data related to vegetation, land use, coastal zones, glaciers. Carto series is basically the observatory systems with high resolution. Our InSat series, which is the geosynchronous orbit placed, they feed to the temperature, humidity profiles, ozones, surface temperature of sea, cloud radiation monitoring. OceanSat series of satellites are for the ice, snow, vegetation, chlorophyll. The SARAL satellite, which we launched some time back, it provides a sea surface height. RISat is the soil, moisture, vegetation. Megatropics of us at CNES joint work, which on the radiation budgeting in the tropical area. We have large amount of sensor development activity taking place, which is focused on the climate change variable monitoring. Also, in the future plans, we are trying to integrate these sensors into our next series of generation satellites. We had two of our important launches. Last launches of PSLV was the SCATSat-1, which is looking at the wind vector data, and also trying to look at the cyclone genesis and its movement. We had the launch of the INSAT 3DR, which is again a dedicated weather satellite, which is going to provide us the data related to the cloud, and it's which had a 19-channel sounder, which is going to monitor that. I would also like to mention about the New Delhi meet where ISRO and CNES jointly organized, where we have taken the desire to take it further on the beyond COP21 on the climate change studies. And I also want to quote what our chairman, Sri S. Kiran Kumar, mentioned, that it is, I quote, "It is overwhelming to see the unilateral support of all the space agencies to use space inputs for monitoring climate change. And Earth Observation Satellite provides a vital means of observing measurement of climate system from a global perspective. And ISRO is committed to the continuity of Earth observation data through thematic series of satellites with improvements en route to meet the contemporary as well as future needs. And ISRO is also engaging with CNES, JAXA, and NASA for realizing joint missions of global climate observations with advanced instruments." Thank you so much.
So thank you very much, and congratulations for this huge program with so many applications. Now, when speaking about climate change, very often the symbol of the climate change is a polar bear, and the polar bear alone on an iceberg which is melting. And in most of the cases, the polar bear is from Canada, and so I have the pleasure to leave the floor to my friend from the Canadian Space Agency.
Thank you. Good morning. I have to say that the Government of Canada is very committed to evidence-based decision-making and environmental sustainability. So strong science and technical research and innovation are critical in achieving these goals. The Government of Canada has taken a strong position concerning the urgent need to address climate change. And our leaders demonstrated this at the Conference of Parties last December, but they also highlighted this priority at home by naming a Minister of Environment and Climate Change. So climate change is an integral part of the Canadian Space Agency consideration and ongoing activities and planning future ones. The fact is, we do not only have to better understand the processes and impacts of climate change, but we also must take action to adapt. So to study and measure, we continue to operate scientific instruments on board international missions, as well as Canadian satellites, such as SciSat, that is a satellite that's providing key measurement of ozone layer for more than 13 years, so particularly looking at the ozone over the Arctic. We explore also new collaborations, opportunities for new collaborations for innovative instruments. These cover a wide range of domains like greenhouse gases and coastal ecosystem. And Canada having one of the longest coastal areas, that is a key focus for us. The Arctic is an area particularly impacted by climate change. We are observing changes in ice cover, and I am sure the majority of you have heard of the Northwest Passage being increasingly accessible. Well, this year we have had the first cruise ship go through it. This increases the need for improved search and rescue capabilities, therefore telecommunication. So we're not talking only about Earth observation system when we're talking about climate change. There are repercussions about our infrastructure and the need to protect it and the need to respond to changing climate and changing environment. RadarSat-1 was started with a focus on Arctic. RadarSat-2 continues to observe the Arctic areas, and the upcoming RadarSat constellation mission will increase the frequency that we look at this area. They are basically right now, RadarSat images are being used to determine safer path for hunting grounds, avoiding thinner ice areas or melting surface ice. Because I think your question also was linking us to the impact of climate change on populations, on health. There is, Canada right now leads an initiative at the UN on space and global health. It's looking at how the two can work together, and climate change has an impact on the health of population. Canada is recognized as one of the leading countries with respect to the depth of research being led on vulnerability to the impacts of climate change and adaptation options. So this gives just a little bit of an overview of what CSA is doing in Canada, involvement in climate change. Thank you.
So thank you. And last but not least, another region which is deeply impacted by the climate change is the northern of Russia, and this is why Roscosmos, the Russian space agency, is so active in fighting climate change. So please, if you can give us your feeling about this issue.
Thank you. К сожалению, Сергей Корякалев не смог по независящим от него причинам принять участие в встрече, поэтому, с вашего позволения, Роскосмос представлюсь Макаров Юрий, директор Департамента стратегического планирования госкорпорации «Роскосмос».
Good day to everybody. Unfortunately, Mr. Sergei Krikalev, who should be present here, could not be present. So let me introduce myself. I am Yuri Makarov, Director of Strategic Planning and National Space Programs of Roscosmos, and I will give a short speech.
В этом году в апреле месяце нами принята федеральная космическая программа. Это основной программный документ Российской Федерации в части вопросов, посвященных исследованию космоса. Мы определились с ресурсным обеспечением, с задачами, которые мы будем выполнять. Цели определены, задачи поставлены, и приступили к реализации этой программы.
So this year we finally had a federal space program approved. So now we have a financement for it, and we have tasks and proposals set before us, and now we can proceed or go forward with implementing it.
В рамках этого программного документа мы планируем нарастить группировку космических аппаратов дистанционного зондирования Земли с 8 космических аппаратов до 23 к 2025 году.
So in the framework of this program, we plan to enhance our remote sensing satellite constellation from current 8 satellites to 23 by the year 2025.
Если сегментировать эту орбитальную группировку по орбитам, то мы предполагаем нарастить орбитальную группировку как космических аппаратов высокоорбитальной системы ДЗЗ, среднеорбитальной, и отдельно еще бы выделил космическую систему для океанографических исследований.
And if we split these satellites in several categories regarding their purpose and orbits, we have 3 groups of satellites. First one is high orbit satellites, second one is the middle orbit, and the third one I prefer to have a specific group of oceanographic satellites.
К первой группе относятся космические аппараты. Это геостационарные спутники семейства «Электро». Они обеспечивают почти непрерывный мониторинг экваториальных и среднеширотных зон земного шара, что дает нам информацию по составлению прогнозов глобального климата. В настоящее время на геостационарной орбите находятся 2 космических аппарата «Электро-Л». К 2020 году мы планируем добавить еще 3 таких космических аппарата, поддерживать эту орбитальную группировку до 2025 года, а также в 2025 году планируем к запуску новый геостационарный спутник следующего поколения «Электро-М».
So in the first group we have geostationary satellites of Electro family. They ensure us with nearly continuous stream of data on equatorial and mid-latitude zones of Earth, and they provide us with data to predict global climatic changes. Currently, we have 2 satellites on orbit. They are Electro-L satellites. By year 2020, we plan to launch another 3. And by year 2025, while sustaining the existing satellite constellation, we plan to launch a next generation geostationary satellite, Dlr M.
Также к этому сегменту относятся два космических аппарата Арктика-М. Мы планируем их запустить в период 17-20 годы. Причем в производственном плане эти космические аппараты, они максимально интегрированы с космическими аппаратами семейства Электро. Эти космические аппараты находятся на орбите «Молния», то есть известные космические аппараты, и позволят нам также получить более качественную информацию о процессах в приполярных зонах атмосферы, что для нас очень важно.
Also, under this first category fall two satellites of Arctica M family, which we plan to launch in 2017-2020. They share a big commonality, technological commonality with Electro satellites, and they will be launched to the Molnia type orbit, and they will enable us to obtain more accurate data on dynamics in a polar region atmosphere, which is crucial for us.
Значит, что касается второй категории, то мы к ней относим космический аппарат Meteor M номер 3. Он планируется к запуску в 2022 году и позволит нам осуществлять мониторинг ледовой обстановки, изменения температуры, а также солености океана, также собирать данные из плавающих буев. Поскольку целевая аппаратура этого космического аппарата новая, практически вся, то мы планируем, что он послужит основой для создания орбитального сегмента космической группировки перспективных космических аппаратов под названием «Океан». И запуск мы планируем этих аппаратов за программный период после 2025 года.
As for oceanographic satellites, we are currently building Meteor M number 3 satellite, which will enable us to monitor ice environment, dynamics of temperature and salinity of ocean layers, and to obtain data from floating bios. As the payload for this satellite is new for us, in fact, it will serve us as platform to develop a new next generation oceanographic satellite family called Ocean. Two satellites of this family planned to be launched after 2025.
Что касается среднеорбитального сегмента, то он представлен у нас уже двумя действующими космическими аппаратами Meteor M, к которым примерно в 2020 году ориентировочно присоединится еще один космический аппарат. Значит, в целом мы будем поддерживать среднеорбитальную группировку в количестве 3-4 примерно аппаратов. И вот та информация, которая приходит с этих аппаратов, нас пока устраивает.
As for the mid-orbital segment, we currently have two satellites, Meteor M, on orbit, and in about by year 2020, we plan to launch the third satellite, and we plan to sustain this constellation on the level of 3 or 4 satellites, which will provide us the necessary information.
Таким образом, созданная к 2025 году национальная орбитальная группировка, по нашему представлению, полностью обеспечит информацией и потребности наших федеральных органов с точки зрения тематики сегодняшнего совещания. Это вопросы определения климата, погоды, то есть информация будет полная. Мы готовы максимально делиться этой информацией, включиться в международную кооперацию, но как это всегда и было, да, и совместно решать те проблемы, которым посвящен наш сегодняшний круглый стол.
So we plan that by year 2025 we will have the whole constellation of satellites which will provide us data regarding climate changes and meteorology, and we will be ready to share this information with our companions, with our colleagues in the international space community.
Dear colleagues, thank you for your attention.
Пожалуйста, 1 минут. Окей?
Thank you.
Окей, спасибо. Okay, so I want to thank all my colleagues for their contribution to this roundtable and for the very important messages they have expressed reflecting their strong commitment to the climate change challenges of the 21st century. As you saw, we made a kind of journey worldwide, and we address this issue in all the countries everywhere which are involved in this fight. And I want to say that the fight against climate change is probably one of the consequences of the new space, because we have many ways to fight this climate change with small satellites, smarter satellites, and at the end of the day, a global effort. This is why we are so much involved indeed. The next important event will be the COP22, which will take place in Morocco in November, and we will continue to discuss about climate change with a specific focus on water issues in Morocco. So once again, I want to thank my fellow panelists, and I ask you to applaud them very strongly. So thank you very much.